In this unit, we're going to talk about types of triangles and how to classify them. First off, we need to know what a polygon is. And a polygon is a closed figure and it's going to have many sides. So if we have a triangle that is a polygon, it will have 3 sides, and a triangle with vertices A, B, and C is called triangle ABC. But instead of writing out the word triangle ABC, we can use the little triangle symbol. In our picture of a triangle here, we labeled our triangle our A, B, C, and each of these are considered sides, and the points where it turns direction is our vertex or our vertices. If we are going to classify the triangle by the sides, there are a couple different ways that could end up. So the first one could be scalene. The second one can be our isosceles. Last one is equilateral, but it's also considered isosceles. And the reason for that is scalene means we have no congruent sides, so none of the sides are the same lengths. In our isosceles, we have at least 2 sides that are congruent to each other. And remember, in our picture, these little markings means that they are congruent to each other. So those 2 sides are congruent sides. For our third figure, we have 3 sides that are congruent, and that is equilateral. But isosceles, remember, can be at least 2 sides, so it could be more than 2. So this figure would also be considered isosceles. We are going to save this last line for after we fill out the angles, because there's going to be another thing we can put there as well once we find out about the angles. But the word equilateral, if we break it down to help you understand what that word means, equa means equal, and lateral is talking about the sides. So later we're going to talk about if it's angles, and we're going to change that slightly for it to be about angles. If we classify our triangles by the angles, we could have all acute angles, all angles that are less than 90 degrees. The next one, we see that there is one right angle in it, and that means that this is going to be a right triangle. The third figure, we have an obtuse angle, and that means we are going to have an obtuse triangle. Now, with an obtuse triangle, it's not possible to have more than one obtuse angle, because obtuse, remember, means that it's more than 90 degrees. And if, say, it was 91 degrees and you had another one that was 91 degrees, that would equal more than 180 degrees. And we know, what we're going to see next, is that all 3 angles will equal 180 degrees when we add them together. So we can't have more than one obtuse angle. For this last figure, we have 3 angles that are congruent, and our triangle is called equiangular. And when you're looking at the word, equa again means equal, angular, we're talking about the angle. So if it's equiangular, that means we're saying that all 3 angles are equal, versus equilateral is all 3 sides are equal to each other. Now, if we have equiangular, we're going to learn some different things, but if it's equilateral, it's also equiangular, that all 3 angles will be the same. And if we start knowing that it's equiangular, we automatically know that all 3 sides will be congruent to each other. So what we're going to add onto our line right here is, if we know that it's equilateral, we know that all 3 angles will also be congruent, because it's also going to be equiangular. So if we have one, then we're going to have the other in there. With our triangle sum theorem, that means that the sum of the measures of the interior angles of a triangle is going to equal 180 degrees. So if we add up all 3 of our angles together, it's going to equal 180 degrees. The measure of angle A plus measure of angle B plus measure of angle C will equal 180 degrees. And our interior angles are each of these inside angles right there. When the sides of our triangle are extended, we are going to have other angles that are formed. So if you look at our triangle down here, these lines, our sides are extended, and now we actually have outside or exterior angles. And the original angles are the interior angles, but the angles formed are going to form a linear pair with our interior angles. And those angles on the outside of our triangle now are called exterior angles. So in my picture, I'm just drawing out what we had talked about, so we know that these are the interior angles, and then instead of drawing it on the same picture, we drew a separate picture. So all of these angles would be exterior angles. And one thing you're going to notice is that if we have an interior angle right here, this exterior angle is not really an exterior angle, those are just vertical angles. And same thing here, if here is my interior angle, here is my angle that's going to be vertical to it. So when we're talking about that the angles create a linear pair, the exterior angles, those are those ones that are going to be right next to the interior angle. So if here's my interior angle, these are the two exterior angles, and they're going to create a linear pair, so not the vertical angle. Because we have those exterior angles, we have a theorem that we can remember to help us with solving for those exterior angles and the measures of them. So the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So in my picture right here, we can see that this measure of angle 1, that's my exterior angle, is going to equal, so you have to set this up as an equation, to the sum of the measures. So I'm going to add two things together, and it's going to be the measures of those non-adjacent ones. So not the one right inside of it, but the ones on the other side of your triangle. So my A plus B will equal my angle 1. So remember that non-adjacent means that it's not next to that exterior angle. So the corollary to the triangle sum theorem is if we have the acute angles of a right triangle are going to be complementary. So the reason of why you can do this is we know initially that all three angles need to add up to equal 180 degrees. That's what I've got. But we know that angle C is 90 degrees. So I carry everything else down. Now if I subtract my 90 to the other side, we end up with that angle A plus angle B is equal to 90 degrees. So knowing that it's 90 degrees for our one angle, we know that the remainder of the two angles also need to equal 90 degrees together. So this is all for the definitions. Now we're going to do some of the examples to work this out. So remember, this exterior angle needs to equal the sum of these two added together. So there's our setup. So we have the exterior angle equals the two non-adjacent interior angles, the sum of those, so added together. Then we can combine our like terms, which there isn't any. So if we need to solve for the x, I can subtract my x to the left, and that gives us x minus 5 equals 70. We can add the 5 to the other side, and we end up with x equals 75. Now be very, very careful, because just like in the past, we want to find the angle of JKM, and that's this outside angle. So we need to take the 75 and put it back in there. So 2 times 75 minus 5. So 2 times 75 gives us 150 minus 5, and we get 145 degrees. Now for number 2, the measure of each interior angle of triangle ABC. So first we need to draw a picture. And it says the measure of angle A is x, 2x is our angle B, and 3x is angle C. Now we don't know anything else other than that, but we do see a triangle, and we know that the sum of all of our angles equals 180 degrees. This means that we can take our x plus 2x plus 3x to equal 180 degrees. So now I want you to go through and I want you to solve for x. What you should have done is add your 3x, 2x, and 1x together, and that gives us a 6x equals 180. If we divide it by 6, then we end up with 30 degrees as our x. But now they want us to find the measure of each of those angles. Since we know that x itself is our A, we can just put the 30 degrees for angle A. B then is 2 times x, so 2 times 30 gives us a 60 degrees. And then 3 times 30 gives us 90 degrees. This would actually be a right triangle since there is a 90 degrees in it. Now number 3 is the same idea, except we know that it's 90 degrees already. So either we can add up all 3 angles to equal 180 degrees like we did for number 2. So the sum of all of them equals 180. But if we know this is already 90, that means that there is a remainder. If we add those together, that will equal 90 degrees because we already have the 90 degrees for the other angles. So we can add these two together to equal 90 degrees, and now we can solve for x, and then it also asks us to find the measures of those angles, so we'll have to plug them back in like we did with the last one. So combine your like terms, we get 3x minus 6 equals 90, and then we know we can add our 6 to the other side. That would give us a 96, and if we take our 96 and divide by 3, we get a 32. Now we need to put those back in, so this angle would be 2 times 32, and that would be 64 degrees. Now for my x minus 6, I would have 32 minus 6, and we get a 26 degrees for the other missing angle. The hardest part about this for classifying by the sides and the angles is we're going to do both of them, but that's not the hard part. It's knowing which word goes with the sides, which one goes with the angles. So for our sides, let's do sides all the way across. We know that we have scalene is when all three sides are not congruent to each other. So if we look at these three pictures, the picture that would be scalene would be our last one. Next, we have isosceles, and that means we have at least two sides are congruent to each other, and that would work for both of our first pictures. But then the last one is equilateral, and equilateral means we have exactly three sides that are congruent, so that would also go for this second picture. I want you now to fill in for the second picture, what's the name for the angle? So because it's equilateral, what is the name for the angles that we know it will be as well? What you should have put is equiangular. Now for the very first picture, we can see the right angle, so we know it's going to be a right triangle. And our last picture, we can see that this is definitely more than 90 degrees, so that will be an obtuse triangle.